Assalamu alaikum. Hello everyone. My name is Altahir Salim Abdullah. Today I'm going to present the application of engineering mathematics in civil engineering. First, we are group 4. Our group consists of 6 members. So I'm gonna start with the introduction. So first, the structural analysis is a vital aspect of engineering design, ensuring the safety and durability of a structure under various loads. Among its key components, the study of beam is essential as their structures members bear loads primarily through bending. Beam deflection governed by Roloni beam theory is a crucial parameter deflection using multiple integration to derive slope and deflection equations for a standard beam. For standard beam configurations such as cantilever, simply support and fixed beam under common load conditions like point and uniform disparate loads. By, by combining theoretical principles with conventional tools, the project provides a reliable format work for evaluate beam performance, offering practical applications in structural design and optimizations, while enhance problem solving and computational skills for real world engineering challenges.
Next, the next part is slope and deflection. Calculation slope and deflection in beams under applied loads is essential for insurance, structural integrate safety, and performance. This calculation help engineering mental structure safety by preventing excessive deflection that could lead the failure or compromise stability, the insurance serviceability. By keeping structure function and avoiding assets like misaligned doors or uncomfortable condition caused by bending, understanding load disturbance allow for the effective design that prevent loosely failures. By optimizing material using engineering can create cost-effective design without compression safety compliance with design kits, which specific allowable deflection and slope ensures that structure meets safety and performance standards. Additional understanding deflection and slope is circle on mitigate as related to dynamic loads such as properties caused by a wind or traffic. In real life applications, slope and deflection calculation play a vital role in building design. Insurance beams can support expected loads in the floors and roofs without excessive bending. In bridge, these calculations are critical for designer graders and trusses to handle vehicle loads, wind strain, traffic, and environmental factors. And space deflection is considered in the design of wings the phyllis to ensure structure integrity under aerodynamic loads. Mechanical compression like machine parts, roller and deflection calculation, the magnitude, alignment, and proper function. Even in furniture design, this calculation ensures product can support expected loads without sinking. In support structure like standing beams and stress and design to handle static and dynamic loads from cord insurance both safety and comfort. This calculation ensures that system can withstand application load while maintaining structural integrity and stability. Okay, thank. That's all for my part. Thank you. Thank you. See you next time.
Hello, Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. My name is Moyed Jamal Khalil, and today I'm going to talk about the problem statement. Beams are critical structure element used in engineering application. Their primary function is to resist bending under applied load, but excessive deflection can compromise the structural system. So, predicting and analyzing the beam deflection accurately is essential so we can ensure the safety. While classic methods for deflection analysis, such as the use of the beam theory and different differential equations, are well established, their manual application can become complex and time consuming for non-standard load construction. Engineers often require precise and efficient tool to calculate deflection, slope, and bending moment under various scenarios to optimize the design. The problem is further compounded by the need to accommodate diverse beam configuration and load type. Without a systematic approach, error in calculation can lead to either over-design or under-design. And by solving this problem, our project seeks to bridge the gap between the theoretical analysis and the practical application, offering a robust solution for engineer and designers in structural engineering.
Okay, Assalamualaikum and hello to everyone. My name is Muhammad Syamil bin Azmi. My metric number ATF 230026. Today I want to talk about the calculation lah of our project. Okay, the question is to consider a simply supported beam is subjected to combination of loading. As you can see as the picture, and the question one is determine the maximum deflection of the given beam by using double integral method. And the second question is calculate the angle of rotation or slope at point A. Okay, the calculation for the question that being given is like you can see it right by my side, is the calculation that I made for the question. As you can see, the first thing you have to make is to calculate the direction at the support lah. To find the direction, the RAY and RBY at the support, the direction. And after you find the direction on the support, you have to find the bending moment equation in the cutting section area lah. You have to cut the section in the beam to find the slope and deflection. It will be easier. First thing you have to do is to calculate the bending moment, and after you found the moment on your cutting section, you have to double integrate it to time to find the maximum deflection. As you can see, like the calculation there is for cutting section, for slope and deflection, you see we double integrate. There is m, the moment is equal to 50x minus 10x square. So when we integrate it one time, it will become 50x square over 2 minus 10x cube over 3 plus c1. And if we integrate it again, it will become 25x cube over 3 and minus 10x power of 4 divided by 12 plus c1 and plus c2. After that, we have to apply the boundary condition. At x equal to 0 and y equal to 0, the C2 is 0, and at x equal to L is equal to the phi lah, because L is the length, and y equal to 0, that will get the C1 is negative 625 divided by 6. So as you can see, we got the C1 and C2. C1 is negative 625 divided by 6, and the C2 is equal to 0. As you can see, to calculate the maximum deflection, x equal to 5 over 2 or equal to 2.5. To find the maximum deflection, the y max, we have to calculate the 25x square divided by 3 x cube divided by 3 minus 10x square at 10x power 4 divided by 12 minus 625x over 6, and you will get the answer is negative 164.761 over EI lah. So, and if we for the answer for the question number 2, to the slope at point A, as you can see at A, x equal to 0. So the dy dx for A is 25x square minus 10x cube divided by 3 minus 625 over 6. As you can see, the x amount is insert in the zero is insert in the x amount. Thus we'll get the A is equal to negative 104.87 over EI for the slope. As you can see, the free body diagram that I draw, as you can see, the first one is the SFD, shear force diagram, and the second one is bending moment diagram that I draw, and for the third one is the deflection curve. As you can see, the Y max is in the middle, that is negative 162.761 over EI. It's become negative, so it goes down, not go up. So for the slope, as you can see, is negative 104.167 based on the calculation over EI, based on the calculation that I calculate just now. Okay, that's all for me. Thank you very much.
Assalamualaikum. My name is Ahmad Shazam Memang Basri. My matric number is DF230001. So my topic about discussion. So I want to elaborate about discussion. So the first is bending moment and stiffness. So for the relationship is between the bending moment is Mx and the beam stiffness is EI, where the E is the modulus of elasticity. So the modulus of elasticity is E, and I is the moment of inertia. It's really is understanding beam deflection. So the second is deflection equation. Deflection equation is y over x, y squared x, and of the beam is found by integrating the second order differential equation twice. We use twice, and the first integration gives the slope, and the second integration gives the deflection. Okay. Third is boundary condition. So the constant is integration and determined using boundary conditions specific to the beam. To the beam was deflect. Uh, Support and the loading configuration. For example, the support beam with a loading at its center will have zero deflection at the support. The second point is for example, for the simple simply supported beam with a point load at the center, just like this. This is beam and the point load. This is point load at the center, and the bending moment M s very along the beam. So the beam is there was maybe moment is deflect. And by substitution ms into the differential equation and performing double integration, you can derive the equation for the slope and deflection. Applying boundary condition help solve for the integration content. Fifth is important of EI. So the importance of EI is stiffness of the beam characterized by EI. Influence its deflection and slope. A high EI result is smaller deflection, ensuring the beam remaining remaining stable under the load.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Muhammad Faisal Shazri bin Tengku Osman Zainuddin. I will continue the present, which is I will present about conclusion. In conclusion, the analysis of deflection and slope on a beam using the double integration method is a fundamental technique in structural engineering that provides a clear and reliable understanding of how beams behave under bending. This method is rooted in the relationship between bending moment, beam stiffness, and curvature, of offering a systematic approach to derive deflection and slope equation. The double integration method highlights the influence of material properties such as elasticity and geometric properties, like the moment of inertia on the beam's performance. That's all from me. Thank you.